The paradox of time refers to various philosophical and scientific conundrums about the nature of time, its flow, and its effects. What if time isn't as simple as we think? What if it bends and warps, changing the way we experience every moment? Could the choices you make today really affect the past? What if you could go back in time and change something? Would it alter everything you know? Ever wonder why a minute can feel like an hour on some days and fly by on others? Is your perception of time just in your head, or is something deeper at play? Here are a few of the most famous paradoxes and concepts related to time. This is probably the most famous paradox associated with time travel. Imagine you travel back in time and, for some reason, prevent your grandfather from meeting your grandmother, thereby preventing your own birth. If you were never born, then how could you have traveled back in time in the first place to stop your grandfather from meeting your grandmother? This creates a logical contradiction, as the event you caused by preventing your birth would also prevent the action you took by going back in time, thus creating a loop that doesn't make sense. This paradox occurs when an object or piece of information exists without ever having been created. For example, a time traveler goes back in time and gives Shakespeare a copy of his own works, which Shakespeare then publishes as his own. In the future, a time traveler goes back in time again and gets the works from Shakespeare, and the cycle repeats. In this scenario, the works of Shakespeare never had a true origin, they exist in a loop without being created by anyone. The paradox questions whether this type of causal loop is possible, and how it fits into our understanding of time. The arrow of time refers to the one-way direction of time, from past to present to future. It seems to flow in one direction due to the concept of entropy, or the tendency for systems to move from order to disorder. However, there's a paradox here. While we experience time as a flowing, linear progression, the laws of physics like those in quantum mechanics or relativity are often time-symmetric, meaning they don't inherently specify a direction of time. The increase in entropy is what gives us our arrow or flow of time, but why and how entropy increases in this direction is still a matter of debate in physics. This paradox arises from Einstein's theory of special relativity. Imagine two identical twins, Alice and Bob. Alice stays on Earth, while Bob travels in a spaceship at near the speed of light. When Bob returns after a certain amount of time, he finds that Alice has aged more than he has. This result is due to time dilation, which states that time passes more slowly for objects moving at high velocities relative to a stationary observer. This seems paradoxical because from Bob's perspective, he's the one who's stationary, and Alice is moving. So, how can time move differently for them? The answer lies in the relativistic effects of spacetime and velocity, but the result still seems counterintuitive, creating a paradox. In theories involving time travel, another paradox arises from the causal structure of time, essentially, how events are connected by cause and effect. If you travel back in time and change something important, it can lead to a causal loop or a contradiction. For example, if you go back in time and prevent a key event like a war, or the creation of a major scientific discovery, it could erase the very reason you traveled back in time to make the change. This gets at the problem of causality, the order and relationship of events. If the past can be changed, it raises the question of whether the future is always determined, or whether it's possible to change the course of events by traveling through time. According to block universe or eternalism, all points in time past, present and future exist simultaneously and are fixed. Time is like a book where every page already exists, and we simply experience it as we read it. The paradox here is how we experience time as a continuous flow from past to future when, according to this theory, everything is already laid out in a fixed structure. This raises questions like, does free will exist in a block universe? Are we simply walking along a predetermined path, or do we have the ability to influence the future? Some philosophers and physicists argue that time might not be a fundamental feature of the universe at all. Instead, it could be an illusion or construct of human perception. For example, the idea of presentism argues that only the present moment is real, and the past and future do not exist. Alternatively, eternalism claims that past, present, and future are all equally real, and time is just another dimension like space. If time is just a mental construct, how do we reconcile that with the reality we experience, where the passage of time seems so tangible? The paradox of time isn't just one simple problem, It encompasses multiple questions and contradictions across both philosophy and physics. From time travel conundrums to the arrow of time and the very nature of time itself, these paradoxes challenge our understanding of how time works. While some are purely theoretical and speculative, others, like time dilation and the paradoxes of causality, are actively explored in the fields of relativity, quantum mechanics, and cosmology. Ultimately, time remains one of the most fascinating and elusive concepts in both science and philosophy.